So all the way from Pittsburgh, Pennsylvania, please welcome my good friend Colin Dean.
Hello and welcome. Yeah, my name's Colin. I wear hats. Not all the time, but especially when I'm at conferences, because it makes me kind of stand out. It's like, instead of trying to find like the kind of chubby white guy with the beard, maybe find the guy with the top hat. Works a little bit better. I'm a software engineer. I build communities as well. I'll talk about that more at the end. Can you hear me clearly? Don't have a whole lot of echo up here, so this works. Of course, the obligatory, my words are my own and not of that of my employers, past, present, or future, and please save your questions to the end. If you can see this text, you will be able to see all of the text. If you can't see it, move a little closer. Here's an agenda for the things that I'm going to cover. I'm recording my own talk for your consumption later. Here's an agenda for the things I'm going to cover. But first, I want to talk about journalism. My first experience with review was with a student newspaper in college, first as a copy editor. I took on layout, picked up a journalism minor, and eventually rose to be editor-in-chief for 2 years, despite being a computer science major in a sea of English majors at a primarily English major and business administration major college. For 3.5 years, though, I read everything that went into the newspaper, everything that was fit to print, and a whole lot that really probably wasn't. Even as an editor, nothing that I wrote went into the paper without being subject to some kind of review. No one was exempt from the red pen, or these days, record changes. That review saved us a few times. Sometimes a student writer would just absolutely wreck a piece, and the copy editor responsible for saying, hey, this is crap, was just too chicken to reject it outright. We, the editors putting together the paper that night at 10 p.m. on a Thursday night, would have to rewrite it ourselves. Sometimes we'd just add our name onto the byline. Sometimes we would replace the byline entirely and put the original contributor's name at the very end, saying they played a part in this piece. You can see the analog on GitHub with that. The best part of this was a bad thing that happened one time my senior year. We would use a lot of X's in headlines as a placeholder for when we couldn't figure out a good headline to write. Headline writing was always a work of art. Well, there was one headline that made it through all of our internal review processes. And it wasn't until pre-press that somebody caught it. One time, a headline that said, "What the fuck is this shit?" above a piece of pizza made it to pre-press. My dear sweet 70-year-old pre-press operator, who had likely been doing her job longer than I'd been alive, calls me up, and see her number show up on caller ID, and says, "Colin, take a look at A8. You owe me a case of beer." So I've been doing reviews for basically forever, doing them, being subject to them. But really, let's talk about what are they. Let's establish a common definition before we go too deeply into this. How many of you have heard of code review? Almost all of you should raise your hand because several of the other speakers today have mentioned something about it. That was really warming to me. I thought a bit and I wrote what I thought, how I would define it. Hello. I wrote, code review is the process by which those who maintain a software code base evaluate a proposed change to that code base, regardless of the source of the proposed change. Per normal, Wikipedia's definition is more succinct. Wikipedia says, code review is the systematic examination of computer source code. This definition allows for some broader techniques than I myself care to participate in or suffer, but the similarity is bolded. The act is an examination, and that examination must be systematic. You may be familiar with the term peer review. and asking, aren't these the same? Well, kind of. I dislike calling them peer reviews, as Carl Wiegers and some other experts on the subject do, because it puts too much focus on the peer whose work is under review, as well as the peers who are annotating the code. By calling it code review, we specify in our nomenclature that we are reviewing code and not the person. Our focus is the code that we're going to have to maintain, not the personalities of the people involved in getting it into production. Interestingly enough, Wiegers actually commented on a text version of this presentation published on the IBM Bluemix blog a couple of years ago. He specifically pointed out the reuse of the term from the scientific community's concept of peer review, specifically peer-reviewed journals. I understand that point, but I feel that the software engineering community can do better, especially after learning a lot about the politics, rigor, and financial incentives of the academic publishing community during the last few years. Moreover, everything is code these days. Architecture and design documents can be expressed in code. You set up your systems with some kind of configuration management or an infrastructure definition software, right? Most of you, some of you, nobody? Infrastructure is code with things like Chef and Terraform and AWS. A typo could be an immediate tenfold cost increase. Throughout this presentation, I'll use these 5 words: change, submission, submitter, reviewer, and annotation. These are probably a little more easily expressed in context. The submitter proposes changes in a submission, which is evaluated by a reviewer who annotates or accepts it. Carl Wiegers describes this peer review formality spectrum in peer reviews in software, where inspection is the most formal and ad hoc reviews are the least formal. My concept of code review and my past and current team's practice of code review falls somewhere between team review and pair programming. We will, from time to time, allow pairs to review their own small changes at their discretion. However, the rule is generally, if you write it, you don't review it. The biggest difference from Wiegers' description is that in no situation where I have any say do we have formal meetings at any end of the spectrum. My engineering teams have found that such types of reviews are inefficient at best and excruciatingly painful for all participants at worst. Rather, code reviews should be conducted at reviewers' leisure. I prefer to do them in the morning. Personally, it gets my brain thinking about code before I actually start producing code. People often produce their best code right before they walk out the door. We use GitHub for our projects. It's a pretty common tool these days. GitHub's pull request system is a pretty stellar example of a code review tool. It's great for leaving comments, referencing code, and pretty good at keeping track of conversations about various changes for a submission. Recent advents of bots and whatnot make it even better. The reviews system that they added in 2016 is fantastic, but I still prefer a good bit of automation in order to make it less political. More on that later. So let's talk about some of the problems that code review solves. It's pretty clear that the primary goal of code review is to find defects before they enter a maintained codebase. However, there are 2 human problems for which code review is an effective tool to solve. Code review solves mental model synchronization. Let's say you've got 5 people on your team. Are you sure that they all have the same mental model for the architecture and its implementation? Probably not. Hopefully they're similar. Code review reduces the feedback cycle so that people can keep their mental model in sync with the architecture and the implementation as it all changes. With that in mind, they're best equipped to mindfully implement the architecture and provide feedback on its design. This gets everybody involved in the architecture and implementation process. But what if somebody has a different idea entirely, one that is so worth exploring that it could change the architecture of the system? This has happened more than once in my team, continues to happen on my teams, and will continue to happen on my teams. Sometimes these discussions on individual lines of code turn into pages-long discussions that turn into new issues, new tickets, new pull requests, architectural changes, and even once a new product. Code review is an excellent way to develop and keep alive tribal knowledge of a project. Tribal knowledge is the sum of stories of what was tried and what was failed, how best to handle certain problems commonly faced, and this concept of how things came to be this way. Any Ishmael fans out there? A part of this is something called architectural oral history. Architectural oral history collapses without a team to keep the culture alive, says Michael Keeling, a former coworker of mine at Vivissimo and IBM Watson. Code review, or more specifically, code review systems, enable a major part of that oral history to be written down, serving as a reference point or even a starting point for documenting the change of the architecture and implementation over time. The most useful review systems make comments searchable for posterity, continuity, and encourage reviewers to extract actionable items from comments into issue or work tracking systems for future consideration. Our team actively does this manually through marking our tickets as technical debt. Code review doesn't just build knowledge of application code anymore, though. Code review can enable developers to continuously review changes to the production infrastructure, testing infrastructure, and have an audit trail with logic and the discussion around the changes. With my setup at work, I'm no more than 10 lines of code, 10 lines of Terraform code, really, and a code review away from launching a new service on our production AWS infrastructure. Code review can enable architects then to continuously review changes to the architecture and to have an audit trail with logic and discussion around those changes too. Developers are included in that conversation too, because the architecture documents should always live in the same repository as the code that they describe. It's not a bad idea to have a system architecture repository as well that describes the interactions between components, but be careful not to dump too much into that repository, lest it become a cesspool. All of this together builds knowledge about how things changed over time and how things came to be this way. So, code review forces us to write it down and make it searchable. This wouldn't be a talk about architecture without talking about quality attributes. So let's talk about some. If you value these attributes in your architecture, then you should definitely be doing code review. When authors move on, who's going to care for the project? People are not forever. They get new jobs, they just up and quit and become nomads, they win the lottery, whatever euphemism you want to use there. Neither are their minds forever. They forget what they did and why they did it after months, weeks, hours. So it's vital that an architecture values maintainability. So let's talk about the first. To me, valuing maintainability in an architecture necessitates that engineers write maintainable code that can be picked up easily and quickly modified by new developers. That's not necessarily new programmers, people who have never programmed before. That's also a very seasoned programmer who's never seen your code before. It also has a design for non-programmers to understand, such that your product manager, your CTO, can understand it as well. Code review drives all of these. The best way to get somebody acquainted with code is not necessarily to throw them into it, not from a go make this change point of view, but rather a come take a look at this code with me. Work together, keep it human. We want them to learn the conventions and the patterns established within the codebase's use of the language, as well as the frameworks of the project. We want both the initial developers and the maintenance mode crew to understand the goals of the architecture and the risks present in the code as it exists today. With this knowledge, they can deal with the problems on their own terms. We want them to use the same terminology as well. We establish a vocabulary that is necessary in order to make the project learnable. And we continue to use that vocabulary consistently throughout the project. This chart shows the modalities for learning in a reviewing situation. Pairing is great, but we need to spend just as much time reviewing together as producing code together. This helps us better transfer knowledge to the next generation of engineers, where, again, the next generation is not necessarily a brand new programmer. It could be a very senior programmer who is your next generation maintainer. We need to point out problems to solidify problem code and have our misunderstandings, our type 1 false positive review comments, corrected by other reviewers who disagree with us. The next generation is not only younger engineers, as I said, but it could be also that sucker taking over for you when you go work on something cooler. It's vital to ensure that the developers on a project understand the architecture and the implementation decisions alike. While they may not be involved in the construction of each decision, code review enables them to be aware of the changes and ask questions about those changes as the project evolves. In doing so, they better understand architecture and implementation, and are better equipped to identify undesirable as well as desirable deviations from the established plan and best practice. This builds tribal knowledge ripe for passing to others, including to executives as well as investors in that proverbial elevator. Serviceability focuses on the ability of a technical support team to provide that support. By exposing new configuration, hiding unnecessary or debugging configuration, and agreeing on use cases that may fall outside of the primary architectural goals, code review drives a consensus on what people supporting the project, supporting the product, will be expected to know and do. This also drives documentation. Linus's law applies here. Problems are more likely to be seen if more people are looking at them. Code review gets more people's eyes on the code. To me, a code review ensures maintainability by encouraging engineers to write code that meets a consensus agreement on maintainability. Code that can be modified quickly, can be picked up by new developers, is thus easy for non-programmers to understand as well. These quality attributes are all intertwined. Systems that are serviceable are understandable. Systems that are understandable are learnable. My first programming job out of school was interesting. We used Subversion. It was kind of neat. Otherwise, our engineering process was go do this thing and don't break the build. We generally just turned off the build. I didn't have to deal with production bugs because the company didn't want us to work outside of business hours. Rare outages were the responsibility of the tech lead, but because he wasn't reviewing any of the code going into the production code base, outages would take a very long time as he needed to go learn what we had done for the last month since the last outage. The lack of code review in this company was a very clear problem. Those outages were rare, but they were caused by entirely avoidable, obvious errors spotted after hours of poring over code. A few months after I left, one guy cost the company thousands of dollars in lost sales because he'd left his own email address hard-coded into an environment variable. Was bad. This mistake was in place for 4 months of a multi-million-dollar imprinting company. He was fired. It was his only mistake that he had ever made in 3 years of working for the company. And that was something that could have been prevented by code review. Secondly, of the three, code review ensures compliance. You have more than one person on your team who's knowledgeable about Section 508 and WACE and ARIA and other internationalization and localization standards. Code review not only aids in compliance by expert review, but can teach best practice, thereby expanding the number of people who are able to be an expert on these subjects. Code review drives auditability. Version control shows what changed and the reason for the change, but it does not describe the decisions that were dropped. You've heard of history is written by the victor. Well, Git history is written by the victorious commit. Idiomaticity, and there's a new word for you, is the quality of using the tools that were chosen for the project in the best way that they were intended to be used. Ever seen Java that looked like C, Lisp littered with lets, Java-style mutable objects everywhere in your Scala? These are violations of the idiom that these tools provide. Idiom violations make for less readable code, and in some cases, less performant code. Writing idiomatic code enables the compiler or interpreter to produce and run faster programs. Another fun story. My second job out of school was a consulting role as an applications engineer. The lack of control and review cost us considerable time and effort. One time, there was a compromised government system that was, compromised but not necessarily exploited government system simply because nobody else was looking at the code. My first professional code review experience, though, was actually a group meeting, a formal inspection in the Spectrum. It was painful. I was always the expert in the room, shouting in the back, "No, you're doing it wrong." But I'd even developed the tool that exported configuration from our product in order to be reviewed because this team needed to review my code, even though it was megabytes of XML. Imagine this, but with just about everybody looking at their mobile or their laptop. The guy leaning back, that's me. Everyone wanted to get ahead in this situation. These contractors were wolves. Incentives weren't aligned. Employees got overtime while already making very lucrative DC defense contractor salaries. Contractors and subcontractors who would exhaust their budget would end up doing free work just so that they didn't look bad during these code reviews. The waste was real. This group inspection involving 2 employees at about $100 each, 1 contractor, myself, at about $200 each, and 7 contractors at $100 each, $150 each rather, for 4 hours. Yes, 4-hour-long code review. Cost all of us in this room, taxpayers, nearly $6,000 per week, or almost $300,000 per contract year. The project did eventually launch, a couple of months late, but by many metrics was not successful, including an 80% uptime rate. The primary contractor lost the renewal. Most of the waste could have been eliminated through a better code review process. The formality of inspections may have been a symptom rather than a problem, though, as I was not party to the discussion that mandated them. Thirdly, code review ensures security. We want to spot vulnerabilities before they ship and teach defensive posture. Linux laws apply here. But the best way to keep out bugs and vulnerabilities in code, don't have code. Yagni, you ain't gonna need it. I get this called on me a lot, and having that happen makes it happen less often. In this situation, reviewers are like your lawyer. You know, the one that keeps you from doing something stupid when you say, "Hey, is this stupid?" And then you go do it anyway. Next, some tips. When should you integrate code review into your process? Well, now. But because the structure of the architecture eventually mirrors that of the developing organization, and vice versa, Conway's law, it's vital that an architecture include code review as not only a technical requirement at the same level as a choice of language stack or inter-process communication methodology, but also as a project requirement that describes how the members of a project development team are expected to interact with each other and provide feedback in order to strengthen the project and the architecture behind it. Think of it even as a part of a code of conduct type thing. According to Best Kept Secrets of Code Review, a case study at Cisco Systems found that there was negligible difference between the number of defects found when reviewing in a formal setting versus an informal setting. For example, the individual review methods I described earlier, while informal reviews were faster and more cost efficient. The ideal review size should not exceed 400 lines of code for any language. Rubyists, listen up. Code review should occupy units of work. That is, if your team is going to use story points or some other system to estimate effort necessary to complete a task, estimate the time necessary to conduct code reviews. My team uses a Fibonacci story point system. Most of our reviews are 1 or 2 points. If it's a big change or potentially controversial change with a lot of input to create and process, it might even be a 3 or a 5. Accept that not everything is perfect. A good code review system will enable reviewers and submitters to create new work items quickly and easily. Identify areas that see a lot of changes and understand why that is. There's an entire field of study devoted to churn, so don't get too deep in with it within the scope of reviews. It's also important not to be petty. Keep it professional and learn to speak through some other medium instead of continuing to bicker electronically through text. Most of all, make progress. Don't let reviews slow down development unnecessarily. Dogpile reviews when they get backed up. No new code until reviews are through. These are the big things that my teams look for in our reviews in general. Certain projects have certain other concerns, but these are largely universal to all languages, all frameworks. I must stress the value and importance of automation here. One of the first things I do now in every code base I touch is to automate style checking, or at least linting. Make sure your syntax is good. When I've done this to existing code bases with existing teams, many of the most frequent corrections found in code reviews simply go away. White space and formatting. Go has been a pioneer in that. This does get frustrating sometimes, though. Notably when the CI system is too strict, or the tool lacks automated fixes, and the local test build system doesn't integrate all of the checks into it. Be aware of that and seek tools and configurations that streamline confirmation, not let it fall in priority to something that everybody hates, forgets, and then tries to disable whenever they don't have fun with it anymore. But most importantly, does it work? And almost as importantly, is it tested? With just a few minutes left, I want to talk about some limitations. Code review cannot easily expose how changes affect the runtime environment. A reviewer is certainly encouraged to download and execute the code as a simple verification if the provided tests are insufficient, but to do this constantly can greatly extend the review period and detract from that reviewer's development time. Reviewers must learn when to communicate person to person instead of continuing a typewritten communication. Drawn-out electronic conversation through text is extremely time-consuming and should only occur when code examples or hyperlinks are necessary to understand the comments. Code review will not get your boss off of you. It will not get QA to stop talking at your door. It will not stop layoffs. In fact, code review can actually be a barrier to one's own ownership of their contributions. A reviewer with an agenda could effectively block a submitter through combative or unnecessary annotations or steal credit for their submission entirely through resubmission. One woman developer, Julie Ann Horvath, cited this as a reason for her leaving her employer, GitHub, later filing lawsuits alleging sexism. She held that a coworker that she had snubbed romantically blocked her work and would waste time altering it needlessly. A counter to this specific problem: ensure that no one reviewer is a bottleneck or a single point of failure, and ensure that multiple reviewers are doing and are able to do code reviews on any part of your system. It's not a bad idea to automate this in some way using an auto-assign bot. The ProBot ecosystem on GitHub does that very well. So that's about it. We've covered everything on our agenda. But you don't have to take my word for it. Microsoft Research published a paper in 2013 entitled "The Expectations, Outcomes, and Challenges of Modern Code Review," a part of which asked developers for their motivations in performing code review. the definition of which, for the purposes of the paper, matched very closely with what I established at the beginning of the talk. From this, we can observe more empirically that some outcomes, of these desired outcomes of code reviewing. All of these are desirable, so you should be doing code review. So, in closing, we've talked about the definition of code review. My new definition is a systematic examination of proposed changes to a code base. We've talked about the problems that code review solves, modeling, knowledge sharing, and the primary quality attributes that code review ensures: maintainability, compliance, security. And we've reviewed some of my tips, suggestions, and caveats about how best to do code review. So, please go forth and review code. But before you do, I got a shameless plug for a community organized Code and Supply. We're Pittsburgh's largest group of software developers. We did the 1,500 person abstractions in 2016, a multidisciplinary conference of which I think I've heard a lot of people talking about it today, so that's heartwarming. We did Uptime DevOps conference in 2017 and Artifacts, a mental health and community building conference in 2018. We've got Abstractions 2019 planning underway with sponsorship opportunities open now. Talk to me. And attendee pre-sale tickets going on sale soon. I'm Colin Dean, and thank you for listening. Obligatory attributions. That's it.